Okay, we're gonna talk about Lewis structure of polyatomic ions here. Okay, what if a polyatomic ion that carries charge? So let's look at this one, ammonium. So this is a polyatomic ion with positive 1 charge. Okay, so we're gonna do the same thing. Nitrogen has 5 valence electrons. Hydrogen has 1 valence electron each, but there are 4 hydrogens. So in total, there's a 5 plus 1 times 4. Now, if both nitrogen and hydrogen stay neutral means they're not losing electrons, they're not gaining electrons. Okay, then they would have 0 charge and 9 valence electrons. But since there's a positive 1 charge, right, that means this whole thing, I don't really care whether it's nitrogen or one of the hydrogen, has lost electron. Okay, so the positive charge resulted from losing 1 electron. And this electron must be one of the valence electrons. We've learned that from module 1 and 2, right? So the valence electrons are used to do chemistry, to be lost or to be gained. So because of this positive charge, okay, you actually have to minus 1 electron here. So just give you a quick summary, okay? If you have positive charge, that means you've lost electron. If you have negative charge, that means you have gained electron. So you just need to correspondingly minus or plus whatever the number is. Plus 1, that means plus positive 1 charge, that means you've lost 1 valence electrons. So you have 8 valence electrons instead of 9. Alright, so since there's 1 nitrogen and 4 hydrogens, so you would put nitrogen in the middle, hydrogens surrounding it, okay? And then put in a 1 bond between each hydrogen, connecting the nitrogen in the middle. Okay, so by putting down 4 bonds, okay, each bond is a pair of electrons. So by putting down 4 pairs of electrons, you have nothing else left. Okay, now hydrogen, we already said this before, guys. Hydrogen does not need 4 pairs, it only needs 1 pair. So you can imagine in any Lewis structure, okay, if you have a 1 bond connecting a terminal hydrogen, then the hydrogen doesn't need anything else. So hydrogens are fine, okay. This hydrogen, all 4 hydrogens are the same. And the nitrogen in the middle, okay, it's currently attached to 4 bonds. So that's 4 pairs. So this nitrogen has 4 bonding pairs already. So that's also satisfying the octet rule for nitrogen. So it seems like everybody's happy. Okay, so this is the structure. But don't forget, this is an ion. It has a positive 1 charge. So you want to square bracket, okay, with a positive 1 charge around it. Okay, let's look at another one. This is a negative 1 charge CH3, okay, very similar to what we have discussed, okay. So carbon has 4 valence electrons, and hydrogen has 1 plus times 3, and the negative 1 charge means it's going to add in 1 more electron here. So this is going to be 8 valence electrons again, okay. Now this carbon is going to be in the middle, and the hydrogen, hydrogen, and hydrogen, okay, 3 hydrogens. Now 1, 2, 3. 3 pairs minus 6 equals 2 electrons. Okay. Now this hydrogen having 1 pair. This hydrogen having 1 pair. Hydrogen having 1 pair. So hydrogen has 1 pair each. That's already good. Okay. The carbon in the middle. Okay. It has 1, 2, 3 bonds. So it has 3 pairs already. It's missing 1 pair, and we happen to have 1 pair of electrons. So we're going to put the pair of dots here. So see this pair of dots does not connect with any hydrogen, okay? Okay, you don't really have to form double bonds unless you really have to, okay? But by putting the double bond here, you're given too many pairs for hydrogen. Hydrogen doesn't want 4 pairs, okay? So keep the single bond and only put the dots, pair of dots next to carbon. Alright, so this carbon now has 3 bonding pairs, 1 lone pairs, total 4 pairs. Okay, negative 1 charge, don't forget that, negative 1 charge with a square bracket. Okay, alright, so this is a couple of basic examples of polyatomic ions.